3, 2, 1. All right, this is Coach Stricker, and I'm here to talk to you about stoichiometry. All right, now in our last unit, in the mole unit, we first went over mass to moles, and what do we use for that? We use molar mass to convert it, or we did volume to moles, and we used 22.4 liters to 1 mole, and that was an STP, and we were able to convert volume to moles and back. And then the other thing we converted was atoms or molecules to moles. And we used Avogadro's number, the 6.02 times 10 to the 23rd, to get there as our conversion factor. Then we had our chemical reactions unit, and we learned how to write and balance different chemical reactions. And so here's an example of one of those right here. O2, oxygen gas plus hydrogen gas yields water, and then we balanced it with a 2 coefficient and a 2 coefficient there. So there's equal number of atoms of both types on both sides of the reaction. And we're going to use that in our stoichiometry problem. And the way it's different from what we did before is you might start off with mass, you might start off with volume, you might start off with atoms of A. And the A in these is our starting substance. That's what you're beginning with, like that's what your given is. And we've always been able to go from, atoms to moles and moles to mass of the same thing, but now adding the chemical reaction part, okay, we're converting to different substances, all right? And the way you do that is through moles. So whatever I start with, I first have to convert to moles every time. So step 1 is going to be convert what I'm at to moles. Then once I get to moles of my starting substance, I'm going to convert to moles of my finishing substance, or my B. I'm going to say B for that. So B is the finishing substance, is what my answer is going to be in. So I go from moles of my starting substance to moles of my finishing substance, and what do I use to do that conversion? I use the coefficients from my chemical reaction. And then I might finish with grams of my start or my ending substance. I might finish with liters, or I might finish with atoms of my finishing substance. So there's a lot of different paths that these problems can go, but the key is you have to convert your starting substance to moles and then convert moles to moles by using coefficients from our chemical reaction. So I'm going to do an example problem here. It says how many grams of water can be made from 54.7 grams of oxygen gas. So the first thing I need to know is, what is my question? Where am I going? It says how many grams of water. So we want to underline, okay, where we're going, right? And then it says can be made from 54.7 grams of oxygen. So I want to underline my starting substance. So when I'm doing the problem, okay, we're going to follow our steps to solving problems that we did in the mole unit before, okay? And the first thing I do is I write down my given, which is 54.7 grams over 1. It's grams of oxygen. And it is very, very, very important that we label. And I know it takes a little bit extra writing, but when you label it, you can follow it. When you don't, you just throw down numbers, that's when we get confused. So label it. The starting number and the starting unit goes on top. The second step, the starting unit goes down. Step 3, the unit of what I'm going to goes on top. So what did I tell you? You have to convert grams to moles. So my first step is going from grams of oxygen to moles of oxygen. And what do I do to do that? I use the molar mass. In this case, it's 31.998 to 1 mole. Okay, that's the molar mass of oxygen. So now I'm here, and I'm going to go from moles of my starting substance to moles of my finishing substance. So I'm starting with moles. So moles of oxygen goes down. Moles of water goes on top. And this is a new step, so this is why we're doing it. So film it so you guys can watch it if you're getting confused. We use the coefficients. So I'm going to use the 2 from here, and I'm going to use the 1 from there. So moles of oxygen is a 1, because that's what the coefficient is. Okay, it's not nothing there, so it's an understood 1. And then the coefficient for water is a 2, right? So that's my coefficient for that. Then am I done? If it asks me for how many moles of water, then I would be done, but I'm not. It asks me for how many grams of water, so I have one more step. So I have to go from moles of water to grams of water, and to do that, I put moles of water on the bottom, I put grams of water on the top, and just like we did before, anytime you have a grams to moles or moles to gram problem, we're going to use molar mass, okay? So that's 18.015, that's how many grams there are in two hydrogens plus 1 oxygen to 1 mole, right? And then when I'm finishing up, I just multiply the numbers on the top, okay? Which is going to be 54.7, okay? So 54.7 times 2 times 18.015 divided by 31.998. All right, and I get an answer of 61.59. And that's going to be in grams of water. All right, now if we're looking at sig figs, I started with 3 sig figs. So my answer can only finish with 3 sig figs. So it's going to be 61.6 grams of water. All right, and then you circle your answer. All right, just like that. All right, so we're going to be doing a lot of practice on these, but that is the simplest way to do it. And that is a 3-step gram to gram problem. But remember, the key is, the new thing is, the only way to convert from one substance to another substance is through moles. And when we do that, we use coefficients. All right, thanks.